Okay, Bryan, we're live.
We're live.
How you
Happy
doing?
Friday.
Yeah, happy Friday. What's going on?
It's been a busy week.
Yeah. So we got a few new things to talk about today.
Yeah.
What we first want to talk a little bit about 5 gigahertz Wi-Fi channels, and I'll put up a chart here that I like to keep for my customers to send out and for me to look at all the time.
Yeah,
Um,
just for like in general, like for
yeah,
general questions and things.
yeah, basically, it shows like the current 5 gigahertz channel allocations. And so this week you said you had a customer with some outdoor access points, and he said they were acting funny. And what did you see when you looked at his configuration in the cloud?
Oh, I want to say it was 10 to 15 access points. They're all outdoor
Yep.
or 11 AC. Um, but he was seeing all the access points on this same channel.
Same channel, and he had them set to auto channel.
He had them set to auto.
Had them set to
So
auto.
he said something was wrong.
Okay, so you went in there and you looked, and he had it set to 80 megahertz, right?
Yeah. That was, I think the second thing I looked at was the channel width,
Yep.
what he had it on. So yeah, he had it set to 80 megahertz.
And these access points do not support DFS channels, the ECW 160.
160s do not.
They do not support it yet. So basically, you're left with only two channels. If you look at that chart, you're left with 36 to 48 and 149 to 161. Are the two channels available? And for some reason, if one of those channels had some noise on it, those APs are probably all auto channeling to the same channel, maybe like 36 or something.
Exactly.
Yeah.
At the current time he was looking at it too, I'm sure.
Mm-hmm. Yep.
So it's gone through a cycle.
So that's not necessarily a bad thing. Like, so let's talk about that. So, let's say he only had one user, which isn't going to be the case ever. But if he had one user and the guy was walking around doing speed tests, then he would probably see great results because those access points they're gonna wait for the other one to stop broadcasting before they broadcast. So they're basically all those access points. How many did he have?
I think 10 to 15, somewhere around
10
there.
to 15. So all 10 of those, and whichever ones are in range of each other, are going to see that one person is using one access point. That guy's going to do a speed test. He's going to see full speed, whatever 80 megahertz is on 11 AC, 2x2. He's going to see full speed like 300 meg or 400 meg, whatever he sees on that. But what happens is he starts adding people, then it would cause a problem. If once obviously he has that many access points, there's a lot of people in there. Then they're all going to be sharing that channel throughput, and they'll be in contention of each other.
Right. Exactly. Yep. Yeah. And that's normally when you have 10 to 15 access points, you don't have one person on there, so that's not the normal case. So, you in some cases you can get away with 80 megahertz with more than like 3-4 access points.
Yeah.
But you're normally going to dial it down to 40 megahertz.
Yeah.
And that's one of the differences from residential Wi-Fi to like business Wi-Fi.
Right.
In a business scenario, you're trying to provide Wi-Fi to everybody, and you have multiple access points, whereas in your house you might have one Wi-Fi router or one access point or two.
Yeah.
So you can get away with 80.
Yeah.
In a business setup, you're probably going to dial it down to 40, and in some cases you might even have to go to 20. But
yeah. So if you're in like a school and you had maybe hundreds of access points, you may actually want to, or an enterprise, you may want to put those channel widths down to 20 so that there's no contention. Now let's talk about so all being on the same channel isn't that bad. That's co-channel interference, but adjacent channel interference would be worse. So if he had one access point on 36 and one on 40, that would be even worse because that would be pure interference, and everyone would be having issues, right?
Yeah. Yeah, so we should probably talk about what we mean by channel width,
Yeah.
right? So yeah, you can set up your the 5 gigahertz. You can do this on 2.4, but we'll talk about 5 gigahertz because that's the band to use right now, right until 6E comes out.
Mm.
Um, yeah, so you're bonding. You have all these channels to select from, and when you start making the channel widths wider, like 20, 40, and 80, even 160, you're bonding channels together, so you're utilizing multiple channels for basically one channel, I guess, or
Yeah.
one path.
Yeah. And you can see the 160s on there. Those are almost never used like in the wild, right? That maybe some like high performance home routers will have that option, right?
Yeah,
But most business equipment doesn't have that option at 5 gigahertz. Probably will at 6 when 6E comes out.
60, yeah,
It'll be usable because the amount of channel bandwidth is huge, so you will be able to use 160. But right now, just don't do it. I mean, if you were so if you had like a router that supported 160 and that you were like miles away from your neighbors or whatever, nothing else around, maybe you could do that and see like super high speed like right around the router, but it's probably not going to cover your whole house. You know, you can add 2 at 160 if you had nothing else out, around there, but still, I haven't really come across anybody using it.
Yeah, we have a guy at work. He's a gamer, and he did buy a 6E adapter, client adapter, mini PCI, I guess.
Yeah.
And he has his buddy has a new 6E router, and he has a gigabit coming into his house. Wireless speeds on 6E or 6 gigahertz. He was getting close to a gigabit, nine something on average when he was like fairly close. And then when he walked away, he was seeing anywhere from 800 to 900.
Nice. Yeah, we'll start seeing those crazy speeds.
Yeah, so that's going to be... I can't wait for 6E to come out.
Yeah, with Wi-Fi 6 at 5 gigahertz, I mean, we're really seeing like more like 650 meg, something like that in optimal conditions. That's kind of what we're seeing at 80 megahertz, which is fine for the home, like you said. Like if you have 2 or 3 access points in your home or small business, you could go 80. But as like you're talking about, you're outdoors where the signal is going to carry further. Then you probably want to jump back to 40 right away.
That's right. Yep.
So how was that problem fixed? You switched him to 40, and then he says, "Oh, it's working better now."
You know what? It's interesting. He had no issues whatsoever. There was no interference problems or anything. He just saw it within our interface. And said, "Oh, there's a problem here."
Yeah.
Like, no, you're just
gotcha.
your configuration.
Gotcha.
Yeah. So we told him that, you could run into issues, and we told him why he could run into issues because you're opening up the door for interference and problems. And, we mentioned the same thing. As more client devices jump on, you're going to see more and more.
Yeah, you see more and more contention for that channel. But, I mean, some, like Aruba, I think, uses single-channel architecture still, right? Like, so they'll run, like, the same channel across, like, a whole zone. Not really sure how they do it or why they do it. Probably, to limit interference, I guess. But yeah, so it's not necessarily bad to be on the same channel if you have a low density type situation.
Yeah. Like in I can't remember. Unfortunately, I can't remember the environment. With 160s outdoor access points, 10, 15, could have been like an RV park or something like that. And so, the users are kind of spread out. So. Anyway. Yeah.
So let's also talk about what the difference is between those. Between the channel width. So the smaller the channel width, the less throughput you're going to have in there, right? Less bandwidth.
Exactly. Yeah.
But it's probably more reliable. So the more you shrink that up, so I don't have the data rates in front of me for Wi-Fi 6, but yeah, the smaller the channel width, the less throughput. So everyone, of course, wants to run speed tests and see the fastest speeds.
Yeah.
And you're only going to see that, with 80 megahertz. But
that's right.
as you add more access points to the business environment, you want it to be more reliable. Have all those access points being reliable, and you're going to limit the throughput a little bit to have better reliability.
Yeah, so like I'm glad you brought up that point, because we see a lot of reviewers online do speed tests, and that's how they kind of like say, oh, this one's responding better, or this one's better than this access point.
Yeah.
And if they have that misconfigured, if one's running 40 and one's running 80 megahertz, there you go. And you see a difference, or there's a difference there. That's the reason why. So by default, we set things up on 40, because typically our access points go into environments that are, you have 10, 20 access points at a time.
Yeah.
But if you're at the home and you're using one of our access points, you want to make sure you go in there and you change it to 80, because you might be able to use 80 no problem.
Yeah.
But we recently changed that, because we were getting a couple of reviewers not changing the radio widths, and they were doing speed tests, and they were getting slow speed tests, so they didn't know or understand how to change that. So we made it by default 80 now, just for the reviewers.
Yeah. Unfortunately, that's how a lot of people will judge Wi-Fi, is the fastest speeds that they see. But when they're actually using it in a business environment or gaming or whatever, like, they may not want to see the fastest speeds. They may want to have the most reliability, so they're not dropping packets or lagging or anything like that. So this stuff doesn't need a lot of throughput. It needs to be reliable. And have good coverage, and that's the way to do it. Right. Let's talk a little bit about power too, because another thing people do is crank the power up to maximum, right? And that's not always a good thing. We've seen, like, just leaving it on auto is probably the best thing to do.
Yeah, we start off with auto. We start off with auto with everything, and as we get closer to the project launching, or as users come on, then we start to fine tune things like channelization, maybe changing like the output power, turning it down for like roaming purposes and things like that, and making sure we have the correct overlap from AP to AP.
Yeah.
But in the old days, we're operating on 2.4 gigahertz. You would crank it all the way up. We had access points that would do like 800 milliwatt.
Yeah, right.
And you just crank it up, and you would walk around with a laptop, and the coverage would be ridiculous. It would be great.
At super slow speeds, though, that you're talking like
super slow speeds.
11 megabit.
About the little bars. Hey, do I have good bars?
Yeah.
Or how many bars do I have? And it was happening in the hotel industry a lot. Like, oh, do I have coverage? As long as I have coverage and I can say I have Wi-Fi, I'm good.
Yeah, right. So that was a thing, right? Because no one was really streaming back then. They were just like loading web pages, and you're like, oh, I see good signal on my laptop.
There's no better yet, there was no mobile devices.
Right.
No mobile devices on Wi-Fi.
Low
it was
power.
Only like laptops.
Right. So the laptops can talk back a little further than say a mobile device with a lower powered radio.
Yeah, exactly. They have larger antennas. Typically the antennas are built into like the monitors and things.
Yeah.
Some are across the keyboard. I've heard. I don't know this for sure, but I'm pretty sure it's just like in the monitor. So the physical antenna is larger. So
right.
You have gain with the antenna, so you have more gain with the laptop, so you can communicate further. Whereas on a small like iPhone, for example, radio output power is a little bit lower. The antennas are smaller because you're trying to save battery. You have to save space. Mm-hmm. So there's a lot of things there. So, if you crank up the output power on a radio, the access point can communicate further, but that doesn't necessarily mean your client device, like an iPhone, for example, can communicate back. It can hear you, but it can't speak back. Mm-hmm. So you run into like a lot of situations, or a lot of problems in those situations, I should say.
Yeah, so you don't want to crank the power anymore. I mean, for a lot of reasons, but like that, even if it can talk back, it may be at low speeds, too low of a speed, and it may not, associate to a closer access point or something, where it should. You'll run into all kinds of problems like that. So just leave it at auto, unless we tell you to change it.
Exactly. So, you and I have experienced, Ingenious is known for having high output power radios on their access points and things like that, and that's kind of changed over time. But with the higher access points like these EWS 360,
Mm-hmm.
that's been a popular.
Yeah.
That's a popular device. It's got what 28 dBm.
Yeah.
And I think the gain on the antennas are like 5 dBi. I could be wrong about that.
Yeah,
4 or
so
5 dBi.
That one has great range, but not like super good speed.
If you put it in auto, the experience is actually really pretty good.
Yeah.
So that's why we saw a lot of that particular access point. So.
Yeah, you don't want to crank the power because just in auto, it's going to optimize your experience. In most cases. All right, so let's talk about hardware availability. So I mean, a lot of people don't understand, like, when you can't get a product you're looking for, like a Wi-Fi access point or switch or whatever, like, why does that happen? Like, there's usually a current generation of product, like the Wi-Fi 6 product that's out now, or the cloud managed product, and then there's like 1 or 2 generations old product, which people are still buying, like the EWS 360 that you talked about, which people really like.
EWS 360, how long has that been around?
It's been around for years. I mean, it still works great. But why would there all of a sudden be a shortage on these older products?
I don't know. I'm making a guess here. I couldn't tell you for sure.
And there is no shortage on the 360. We have them in stock right now if anybody wants them. But we're just an example of older chipsets.
Yeah, because you're seeing it across the board, and you're talking about access points, but the one you should be talking about is switches.
Yeah.
Switches are becoming a major problem. So with the pandemic, the demand doesn't necessarily go away, but it kind of like it slows down. So manufacturers adjust to that demand, right? So maybe they have like 10 manufacturing lines, and now they're down to 5 manufacturing lines, and you bring those manufacturing lines down, and so your capacity to build product is now lower, and so that carries all the way through to like a chipset vendor, for example. But that's the one experience that I've heard before, but I'm not sure if that's the 100%. That's the reason why. But we are starting to see that this is becoming an issue. Like typically, because we're a manufacturer, we're actually a manufacturer. We are able to bring in the components that we need for our customers. So. We're pretty resilient in those kind of situations. But yeah, I mean, we're starting to see it a little bit from our side, but I know you're experiencing it as well with other vendors.
Yeah, we're seeing some shortages here and there, and it's sporadic, but what I wanted to hit on is like the older, say you're using an older device and you're buying a lot of them still, those older chipsets, they may not have components for them anymore.
Like 11N. There's another manufacturer out there. I won't say the name, but there's customers that still use 11N, 11AC. Obviously, they're still using, but they're having really real difficulties with 11N products, 11AC products. So the older products, you're going to see more and more problems with availability because it's just not available. And maybe you have one vendor that's buying that particular chip, and you don't have a bunch of vendors buying that chip. So, the company that's making that product, there's less demand for it, so they're not going to manufacture it necessarily. So
and as you said about the switching, like with everything opening back up after the pandemic, there was probably less office in like school build outs, but now all of a sudden they need to go back in there and assess what they're going to need going forward.
Yeah, we actually performed pretty well through the pandemic, surprisingly. So we continued like the cloud line continued to grow.
Yeah,
it continues to grow. So it didn't hit us as hard, but we've noticed like these large projects coming in now. Back in. So so you're right. So everything is kind of like turned off for a little bit, and then now everybody's back or starting to come back, and then these projects are coming in now.
Yeah, so just be a little more flexible, I guess. If you decide you want this access point, maybe talk to me or Bryan and see like maybe you should use this one because we know that there's a good pipeline for this product right now.
That's right.
So you may have to be a little flexible on which access points and switches that you're choosing, but other than that, I mean, the demand's really been there the whole time, and it seems to be going up now even more.
Yeah, for us, it's been really steady and growing, and now it's really starting to grow. So that has been something that we've seen. But yeah, as like what you're saying, Jeff, I would bring in if the project calls for 10, maybe you bring in 12, or if your project is for 50, you bring in 10 or something like that. So I would definitely have extras on hand, just to be on the safe side.
Yeah, for sure. All right, so let's talk a little bit about troubleshooting with the switches in particular. So I know we talked about this issue or this case we were working on a couple weeks ago, where we're trying to troubleshoot over the cloud switch now. So in order to see exactly what's going on, sometimes you have to do a packet capture with something like Wireshark, right?
Yeah. Yeah. So if you have a wired device that's connected to a particular port, and you're trying to identify an issue on that particular port, you want to do a packet capture on that port, for example, and then pull that into like a Wireshark and try to identify the issue.
Yep.
Basically. So I think you use it too.
Yeah,
well, right?
I use it too. So some switches have the ability to do a packet capture right on the switch, so that then they can upload that to engineering, or you can look at it with something like Wireshark. They use like a PCAP format, which is pretty standard, right? So some switches have that ability. Otherwise, you would have to basically span the port and have a PC there doing the capture locally, right?
Yeah. Basically, you're gonna have to roll somebody out there, right?
Yeah.
And have somebody do it for you. If you have an end user that has, like an office, a professional office, and that they have voice over IP, for example, and they have one-way audio, you're gonna have to, do a packet capture on that.
Right.
Actually, you're gonna have to do a packet capture on that port and have them actually make the physical call to see what's happening on that particular, or what's happening with the data, and then pour it into like a Wireshark or whatever.
Which is tough because you have to have that setup going when they're going to use the application. So if you can do it through a cloud, through the cloud or the cloud switch, or engineering can do it through SSH or something like that, that makes it way easier, right?
Yeah, and we recently had to do that. I don't know if you want to talk about this, but with our guy Jeff.
Yeah.
Other Jeff, the issue that we ran into. If you want to talk about that.
So that issue was resolved using basically packet capture.
It was a packet capture.
Yeah.
And Wireshark.
So that was what, an incompatibility between the device he was using and maybe in some of the new switching hardware that's in these switches.
So we have a new 10 gig switch and multi-gig switch, and so obviously they're new chipsets.
Yep.
So you can test your product with a bunch of different products, but you're not gonna get everything. You can't test it everything. So we were working with a gentleman that was using a video
encoder. Yeah, it's like video encoder.
Yeah, and so so there was an incompatibility there where it actually slowed the speed down.
Yeah.
Right.
Yeah.
And so we had to do a packet capture on that and identify what was the cause and what was going on. But with the cloud product, the feedback on that is really, really fast.
Yeah, so you guys were able to take a capture, generate a patch for the switches, and fix that issue all remotely. Now, I don't know any other vendors, manufacturers be able to do that in that short of a time, for their customer.
Okay, the capabilities, they definitely have the capabilities, but at the speed that we do it, I don't think they do.
No, I mean, I don't. That's one of the big advantages of Ingenious. I mean, that they can come in, and I'm not going to do this all the time, of course, but if there is an issue, they can come in and fix it really fast, where others are just going to wait. They're going to put you through their turbo ticket maybe wait for a quarterly roll up in the software to fix it.
Yeah, exactly. So whereas I mentioned that Ingenious is a manufacturer, like an actual manufacturer, we have a very large R&D group which consists of software engineers, hardware engineers. So that's how we can speed that process up. The other thing that we talked about is that online, the chat support within the cloud interface. So we can receive feedback immediately through that channel and respond to those types of issues. So
nice.
That is the beauty of that.
All right, Brian. So I think that's good for this week. So remember to like and subscribe for more help with Wi-Fi.